Welcome back everyone to this discussion on matrix plots. Matrix plots are the visual equivalent of displaying a pivot table. Basically, a matrix plot is going to simply display all the data that's passed into it, essentially visualizing all the numeric values in a data frame. Now because of this, it's important to note that not every single data frame is a valid choice for a matrix plot such as a heat map. And there is essentially two types of matrix plots that are available for us in Seaborn. The two main types are first the heat map, which is going to visually display the distribution of cell values with a color mapping, and then a cluster map, which is actually the exact same visualization as a heat map, but first what Seaborn does is it conducts a clustering to group together very similar data rows or data columns, and then we can see which groupings are most similar before we actually visualize it with color. So let's start off with the heat map. Here what we have is a bunch of information on different things like birth rate, mortality rate, infant mortality rate, and the averages of all these rates for the countries based off what region they're in. So we have all the countries in Africa, all the countries in Asia, in Europe, Latin America and the Caribbean, North America, world, etc. So what we can see here is the actual values, for instance, for the birth rates for the different countries within Africa versus within Asia. And what's a little hard to tell when you're just looking at all the numbers is what countries and what regions are similar to each other versus what regions are quite different, and then how they compare to the overall world average. So instead what we could do is use a heat map to visualize this through the use of color. And now I can easily tell what regions are similar to each other for things like birth rate versus mortality rate. Now you may be wondering, here, I had 5 columns with rates and then a life expectancy in years. However, when I pass this into the heat map, I now only have the rate columns. So why is this important to note? Well, a heat map should ideally have all the cells be in the same units, so the color mapping actually makes sense across the entire data frame. And in this particular case, all the values were the rates of percentage growth or change that are in the heat map. So again, here we're only showing rates because it's essentially the same unit. It's going to be something like percentage. Let's imagine what would happen if we included age. Life expectancy was in years. It's not an actual rate of change for life expectancy. So in that case, we're dealing with a completely different unit, which is why that column is just a completely different coloring. And now a lot of those rates, the differences between them are harder to distinguish because the color mapping has spread so wide. So ideally, and this is the main reason why not every data frame can be passed into a heat map, is that all the cells should have the same unit, which is why having everything be a rate of change or a rate is going to be correct for a heat mapping such as this. But the minute you start adding in different units like years versus rate, then your numbers are going to be completely off from each other, basically reducing the effectiveness of this actual color mapping. Now, I did mention that Seaborn also comes with the ability to automatically cluster similar groupings together. And later on, we're actually going to discuss how this clustering is done mathematically when we learn about the machine learning clustering techniques. But for now, just assume that Seaborn is doing something on the back end to group together similar rows or similar columns. So, for example, if we wanted to cluster together both rows and columns, we could get something that looks like this. And essentially what it does is it reorganizes the columns and rows so that regions, in this case, like Africa and Europe, or Oceania and Asia, that are similar to each other, they're going to get grouped together depending on what we're actually looking at. And the hierarchy clustering is shown through the use of these lines. So, for example, we can see here that it looks like the birth rate and infant mortality rate are in a similar grouping as far as their values are concerned for Africa. That would be those two top left squares. So those are clustered together as far as the rates are concerned. Okay, so let's go ahead and get to coding out these matrix plots to further explore this with Seaborn. All right, here I am at the Jupyter Notebook. I've gone ahead and done my imports. So what I'm going to do is read in a new data set that we haven't worked with, but I just showed it in the slides. And it's the World Population Prospects published by the United Nations. And essentially starts estimating different things like birth rates, mortality rates, life expectancies for countries, and then it kind of averages them out per regions. So let's go ahead and read this in. I'm going to read in countrytable.csv, and you'll notice here when I read this in that technically the label here is countries, but these are more like geographical regions. The reason they call countries here is because it's essentially all the countries in Africa kind of averaged out here. All right, so we have this data frame, and in order to pass this into a heat map, what I need is a labeled index. That way I can see the numerical information against two labels, the column labels and then the index labels. So obviously countries here is a good candidate for that labeled index. So that means I'm going to say df is equal to df, and I'm going to set the index to countries. And this is yet another reason why not every data frame is a good choice for a heat map. So we go ahead and set our index, and now we have something that looks perfect for a heat map. I have labeled columns, a labeled index, and then numerical values. And for a large table, you can see that it starts to get a little hard to immediately distinguish different birth rates across the different regions or mortality rates compared to birth rates, etc. So now we have a really nice candidate for a heat map. And the way to do this is it's kind of similar to pair plot, where you just call heat map and then pass in the data frame itself. Now, if you pass in the entire data frame, we have the problem that I mentioned in the slides where one of these columns is in completely different units than the other columns. Here, we're all dealing with rates, like birth rate, mortality rate, infant mortality rate, and general growth rates. Life expectancy, however, is in the units of years, which is just completely different, and you'll notice the scale is completely different. Here, we're dealing with ages of like 63 to almost 80 as far as life expectancy per regions. But here, for rates, it wouldn't make sense to start comparing years to rates, which is why suddenly the color mapping is completely off here, and it looks almost like everyone has a similar growth rate. But let's go ahead and drop that life expectancy column. So say df.drop life expectancy. Let's make sure we spell that right. So for lowercase e, life expectancy along axis is equal to 1 since it's a column. And now we can see that certain growth rates are much higher than others. So Europe has a much lower growth rate and Africa has a much higher one as far as the regions are concerned. So dropping that and making sure everything is in the same units then allows us to see the differences. Another thing that can help clarify this is by adding a little bit of a line between these cells, and we can do this with the line width parameter. So I can say line width, and if you say 0.5, you'll notice it adds in a little bit of spacing here to make it easier to read. And the other thing is sometimes you don't just want the colors, you also want the values themselves. So you can just say annote for annotate and set it equal to true. And what Seaborn is going to do is it will automatically put in those numbers as well. And if it gets a little too blurry, we know that we can also always say PLT figure and start editing the fig size or just edit the DPI in order to make the image just a little sharper. Okay, so something to note here is the color mapping by default is this color mapping, I believe it's magma, inside of Matplotlib. And in general, you want to be extremely careful when you're choosing color mappings for a heat map, because someone that is visually impaired through color blindness can only see the distinguishing colors on certain spectrums. So what we want to make sure is that we choose the correct color mapping. And luckily for us, the default here should be viewable by someone that's colorblind. There's actually certain color mappings within Matplotlib and Seaborn that by default, they pretty much always choose something that is okay for a viewer who's colorblind. If you do want to change it so it matches maybe some other color scheme that goes maybe more in line with your corporate presentation or something like that, always be careful on choosing a heat map. In general, one of my preferred heat maps is the Viridis heat map. So it's VIRIDIS, and you'll notice that in this case, I don't say palette, I say CMap for color mapping. And if you run that, I personally prefer this sort of color mapping because for me, the extremes jump out a little more than the sort of magma color mapping. So clearly Africa has a much higher infant mortality rate than some of the other regions in this list. And also we can see here that Europe, clearly their growth rate is much lower based off both the number and the coloring here. So this is my preferred color mapping for heat maps, but obviously it depends on kind of your choice. The other thing to note here is technically you can play around with this color bar as far as where you want it to be centered. So right now we're essentially going that the lowest value is going to be the darkest color and the highest value is going to be the lightest color with this yellow. But technically you can center this color bar wherever you want. So it matches up with the color mapping and then centers the color map to whatever value you want. I would recommend that you don't change this, but it is available to you in certain situations that you want to change it. For example, I could say the center of the color bar itself is going to be at 40. So when I run this, what is not actually changing are the values themselves. What's actually changing is this color map itself that goes all the way from dark purple to yellow. I want the center, essentially that coloring, to be at 40. That means you have to go much past 40 in either direction to start getting the yellow. So that's how you can affect the color mapping itself to maybe try to show maybe that these rates are more similar than you want to show. But again, in general, I would suggest you don't edit that centering in order to use kind of the default color mapping scheme. And then the other plot type that we were discussing was the cluster map. So if I, instead of heat map, I say cluster map, and say cluster, what it's going to do is it's going to cluster together the groupings of both these different column rates as well as these country regions, so that similar country regions and similar rates are going to be grouped together in a hierarchy. So we can see here that I've grouped together both the rates as well as the country regions. So you can kind of determine here which rates are more similar for Africa. And so we can see these two rates happen to be much higher, so they're separated into their own cluster versus these two lower rates for Africa. And in general, that tends to be the similar rates across all these countries. So it's clustered them together, which kind of makes sense because it's the birth rate and infant mortality rate. It would make sense that these two are related to each other. So it went ahead and clustered them together. Keep in mind though that in certain situations it doesn't make sense to actually cluster the columns together. So what you could do is simply say column clustering or call_cluster is equal to false, in which case it's only going to cluster the index together. And obviously you could transpose the data frame in case you wanted to switch this. But we can turn off the column clustering here, and now I have only the regions themselves clustered together. So what does that mean? Well, let's go ahead and look at these clusters. Looks like I have a clustering bar here, which means Europe and North America in general are more similar to each other than the other groupings. And we can see here that it looks like Asia and the world are more similar to each other than Asia versus another grouping. And in general, that makes sense because of Asia, it holds so much of the world's population that it's going to be more aligned with the entire world than versus any other particular region. And Europe and North America are a little more developed than some of these other regions, so that's why they're also clustered together. And then we can see the groupings of which clusters then are clustered together and higher levels. Okay, so that's pretty much it for the heat map and cluster map. Obviously pretty easy to use. The main things you have to consider are to make sure that all your cell values are in the same units. And then after that, you just call heat map or cluster map on them and then edit the parameters so you get a nice looking matrix plot. Okay, that's it. You can check out the Seaborn documentation for more information on that. But coming up next, it's time to test your skills with Seaborn with some exercises. I'll see you there.